Hi, very good morning, students. Let us see the next topic called asynchronous counter. We are going to design a 3-bit ripple down counter or 3-bit asynchronous down counter. In the previous video, we have seen how to design a up counter. Now we will see how to design a down counter. You know, down counter counts from n minus 1, n minus 3, so on till 0. Okay. Now the circuit diagram, let us see the circuit diagram to design the 3-bit ripple down counter. Since I said 3-bit, we are going to use 3 flip-flops. Flip-flop 1, flip-flop 2 and flip-flop 3. Okay. So what flip-flop I'm going to use for the design? I'm going to use T flip-flop. You know, any flip-flop will have an input T, output Q and Q bar and a clock. Right? This is the construction of a flip-flop. Any flip-flop, there would be as input, there would be an output Q and a complement Q bar and a clock connected to the flip-flop. Clear? So, can you see the construction? The first, since it is asynchronous counter, you should understand asynchronous means only the first flip-flop will be provided with the clock. To the second flip-flop, output of the first flip-flop Q0 will be provided as a clock of second flip-flop. Can you see? For second flip-flop, Q0 will act as a clock. For the third flip-flop, Q1 will act as the clock. So output of first flip-flop will be acting as a clock of second. Output of second flip-flop will be acting as a clock of third. Right? Now what is that we are going to do is, we are going to see about down counter, and we should understand this counter will work only in the negative edge of the clock pulse. Can you see? This is the negative edge. If this is a pulse, clock pulse, this is positive edge and this one is negative edge. Clear? This one is negative edge. When it moves from 1 to 0, I call it as negative edge. Can you see this arrow mark? This arrow mark indicates the clock will work in the negative edge. The bubble is negative. The star is edge. Negative edge. Clear? So, sorry. Bubble is negative. Triangle is edge. Negative edge. Clear? So let us start working. And where we will get the output? If it is asynchronous up counter, outputs are obtained from Q0, Q1, Q2. Since it is down counter, outputs are obtained from Q0 bar, Q1 bar and Q2 bar. Clear? Let us see the construction. First, to design a down counter, we need to design an up counter. So in up counter, I said you will get outputs from Q0, Q1 and Q2. Q0, Q1 and Q2. In down counter, you will get outputs from where? Q0 bar, Q1 bar, Q2 bar. It means I need to first get the outputs Q0, Q1, Q2 and complement this output so that I get what? Q0 bar, Q1 bar and Q2 bar, which will form what? The down counter. So let us start with the up counter. Let us start with the construction. Now this is my clock. Can you see clock is sequence or of pulses. So this is my clock with sequence of pulses. Done. Now since the clock is negative edge, bubble and a triangle. Bubble is complement, triangle negative and this is a edge. So negative edge. What is negative edge? Downfall. That is 1 to 0. This is a negative edge. This is a negative edge. Give arrow marks to all negative edges. Done. Now let us start designing Q0. How will I get Q0? I will write Q0 here. Initially, think Q0 is 0. Okay, this is assumption. Think Q0 is 0. Whenever I get a negative edge, can you see? There is a negative edge. It is dropping from high to low. Whenever I get a negative edge, my T flip-flop, toggle flip-flop toggles from 0 to 1. Clear? So I will be in one state till I get or till I encounter next negative edge. Since I am getting my next negative edge here, till this point I will be only in 1. Since I have got next negative edge, what happens? This 1 will toggle to 0. I will be in 0 till I get my next negative edge. In this point, what I will do? I will toggle from 0 to 1. I will be in 1 till I get my next negative edge. Okay. 1 will toggle to 0 till I will be in 0 till I get my next negative edge. 0 will toggle to 1. I'll be in 1 till I get my next negative edge. 1 will toggle to 0. So when I move from 0 to 1 or 1 to 0, only when my clock is in negative edge. When my clock is negative edge, I trigger and move and toggle from 0 to 1. If it is negative edge, I trigger, I toggle from 1 to 0. Clear? So this is my Q naught. Now I need to do what? Q1. You know Q1 is the output of second flip-flop. Okay, Q1 is output of second flip-flop. Now in second flip-flop, Q naught of first flip-flop, output of first flip-flop will act as a clock of second. So for second flip-flop Q1, what is acting as a clock? Q naught is acting as a clock. So for Q1, I should leave this clock. I should treat Q naught to be what? Clock. Can you see? For second flip-flop, Q1, output is Q1. Clock is what? Q naught. Q naught is acting as a clock of Q1. For Q1, Q naught will act as a clock. So whenever my clock is in negative edge, only then I move from 0 to 1. Clear? So how many negative edges? This is a negative edge. So one transition, second negative edge, second transition, third negative edge, third transition, fourth negative edge, fourth transition. Clear? So I start with 0. I will be in 0 till I get what? Negative edge. I got negative edge, so I will transit from 0 to 1. I will be in 1 till I get what? Negative edge. Clear? So I will move from 1 to 0. I will be in 0 till I get what? Negative edge. I will move from 1 to 0 to 1. I will be in 1 till I get my what? Negative edge. Now I moved from 1 to 0. So now do for Q2. What is Q2? Q2 is the output of third flip-flop. Okay, so for Q2, what is the clock? Q1 acts like a clock of Q2. So Q1 is the clock of Q2. So I will be in 0 when my Q1, can you see Q1? Where is the negative edge of Q1? This is the negative edge of Q1. Okay, where is one more negative edge? One more negative edge is at this point. So when I do the transition only during the negative edge, I start from 0. I'll be in the same 0 since I'm not getting any negative edge. Here I got a negative edge. I get triggered and move from 0 to 1. I'll be in one state till I get what? My negative edge. Since I got a negative edge, now I move from 1 to 0. So for Q naught, clock is considered. For Q1, Q naught is considered as a clock. Q naught is considered as a clock for Q1. For Q2, Q1 is considered as a clock. Q1 is considered as a clock. This is how we get outputs at Q naught, Q1, Q2. This is up counter. If they ask in the exam, explain asynchronous up counter, draw this structure, draw this timing diagram, this is done. It is asynchronous up counter. Now how to get a down counter? From up counter you need to design a down counter. You know down counter means what? Outputs are obtained from Q0 bar, Q1 bar and Q2 bar. So what is Q0 bar? If Q0 is 0, make it as 1. Complement Q0. 0, 1, 0, 1, 0, 1, 0, 1. Make it as 1, 0, 1, 0, 1, 0. Just invert Q0. 0 means low ma, 1 means high. 0 is low, 1 is high. What is Q0 bar? In the place of 0, make it 1. In the place of 1, make it 0. This is Q0 bar. What is Q1 bar? 0, 0, make it as 1, 1. 1, 1, make it as 0, 0. Invert it. Done. What is Q2 bar? All zeros will become what? All ones. All ones will become what? All zeros. Right? Now see this. 1, 1, 1 is 7. 0, 1, 1, 6. 1015 0014 sorry 1004 011 3 0102 0011 000 is 0 again started with 7 111 is 7. It means what is the job of down counter? It down counts from 7, 6, 5, 4, 3, 2, 1, 0. After reaching 0, again it starts with 7. Since it is 3 bit, 2 to the power of 3 is 8. So it has totally 8 states, 7 to 0. Since it is a down counter, it down counts from 7, 6, 5, 4, 3, 2, 1, 0. After it reaches 0, it starts again back with 7. So this is the design of what? Asynchronous 3-bit down counter or ripple 3-bit down counter. Thank you.